Hello friends, welcome to Alphanumeric Tricks. In last video, we have seen that problems under the topic first order non-linear partial differential equations. Under that, we have seen that how to get the solution of type 4 separable equations. And this video is the continuation of the previous video. And here we are going to see how to get the solution of separable equations type of problems one by one. The previous video link is available in the description box. If you want, please have a look on it. Now we will see how to get the solution of p squared y into 1 plus x squared is equal to qx squared. Here we start with the problem 3. The remaining two problems are under the previous video. Now number the given problem as equation 1. And then here we have a p, y, x term and q terms is there. That is p, x, y, p, q term is present in our problem. So this is of the type 4 separable equations. That is f of x comma p is equal to y of y comma q type of problems. And here we have to find out the solution for this type of problem. Okay, problem is asked to solve. So we have to find out complete integral, singular integral and general integral. As usual, the same story. You have to remember the that is procedure for the all the types. We can easily get the solution of the nonlinear first order equations. Okay, so here only thing is the singular and the general integrals are same procedure for all the types. The complete integral alone is differs. So you have to remember that. Okay, once you remember, we can get the solution. What is the complete integral for this type of equation? That is in a separable equation. Just we recollect with a second. You have to separate the variables and then equate it to constant, and each is equated to the same constant, and then we are using that we have to find out the values of p and q. That is substituted in dz is equal to p dx plus q dy. Integrating, we can get the complete integral. That is the procedure. Now we will see how to get the solution. Before going to write the complete integral, we have to write this is of the separable equation f of x comma p is equal to phi of y comma q. Now we have to separate the variables here. When you are taking this y terms to your right hand side denominator and x square terms to your left hand side denominator, then we can get px terms are separated and qy terms are together. So p square into 1 plus x square by x square is equal to q by y. That is equated to some constant a. After that, each term is equated to this constant. Okay, that is the procedure. So p square into 1 plus x square by x square is equal to a, and q by y is equated to a. From this, we have to find out the values of p and q. So in this equation, p is when you taking this p square into 1 plus x square, and you have to take the x square to the right hand side. So you have p square into 1 plus x square is ax square, and q is equal to ay. Now from this, you have to take this 1 plus x square also here. So in the right hand side denominator, then only you can get the values of p square. So p square is equal to ax square by 1 plus x square, and q is equal to ay. After that, you have to take the square root of p square is equal to ax square by 1 plus x square. So we get p is equal to x into root a, because root a is there. So when you are taking square root, you have root a. X squared is there, so you have x divided by root of 1 plus x squared, and q is equal to ay. We get the values of p and q. What is our next step? We have to substitute this p and q values in dz is equal to p dx plus q dy. So what is the values of p? P is equal to root a into x divided by root of 1 plus x square, and q is ay. Substitute the values here. Dz is equal to x into root a divided by root of 1 plus x square into this dx plus q is ay into this dy. Now we have to integrate this equation. So we have integral dz is equal to integral of x into root a divided by root of 1 plus x square into dx plus integral ay dy. Now we have to make use of the substitution method to get the integral value of this integral, because whenever you have x dx is there in your numerator and denominator you have a root of 1 plus x square or 1 plus x square term, whatever at the terms like that, you go for a substitution method, then you can easily get the integral value. So make use of the substitution. 1 plus x square is equal to t square. Okay, because root is there, so we are taking 1 plus x square is equal to 2 square. Okay. Now we have to differentiate this. What is the differentiation of x? Right hand side, sorry, left hand side x square 2x dx. One is constant, it becomes 0. So x square differentiation is 2x into dx plus t square differentiation is 2t into dt. Okay, and now 2 get cancelled. So x dx is equal to t dt. That is substituted in this integral. Okay, so integral dz is z, which is equal to root a is constant. Take it outside from the integral, and root a into integral of x dx is replaced by t dt divided by root of 1 plus x squared is replaced by, that is 1 plus x squared is replaced by t squared. So you have a square root as it is. So square root of t squared plus integral of ay is a into y, a is constant, so integral of y dy is y squared by 2 plus the constant of integration c, and here t and root of t, what is root of t square? T. So t get cancelled. So we have z is equal to root a into integral dt plus a y squared by 2 plus a constant. And what is integral dt? T. That is written here. And after that, don't forget don't forget this to write the original variable here. Okay, and we have substitution method only we get the answer. So we have to substitute the original value here. What is t value? When you taking square root, t is equal to root of 1 plus x square, that is substituted here, plus ay squared by 2 plus a c, which is our number that equation has 2, which is our required complete integral. Okay, now using this complete integral we have to find out the singular integral. Okay, so singular integral, what is the procedure? We have to differentiate the complete integral partially with respect to the available arbitrary constants, and using the rule dou z by dou a is equal to 0 and dou z by dou z is equal to 0. This is also differentiated with respect to the available arbitrary constants in the complete integral. And also whenever you have the problem, that is your problem is c alone is separately there in our complete integral, so you try to differentiate that first, then we can within a second we conclude our singular integral. Okay, so differentiating 2 partially with respect to c, then you have dou z by dou z, which is 0, is equal to, this term becomes 0, constant differentiation, and this is also constant because c is different with respect to c we are differentiating. So this is also 0, c differentiating with respect to c is 1. So 0 is equal to, which is an observed result, that is impossible result we got it. So we can conclude that there is no singular integral for this given problem. Okay, and here and in all the 4 types, the complete singular integral exists in which type of problem? Did you remember that? As clear as form only we can get the singular integral. Remaining all the 3 types, most of the all the problems we conclude the result like this. There is no singular integral for the problem, because all the problems we get the observed result, and all the problems and all the remaining 3 types except clear as form in a complete integral c is separately there. Okay, that's why c one constant is separate. Not c we can, according to the different constant is we are taking. So in this one constant is separately there. So we except clear as form, remaining 3 types there is no singular integral. We get the observed result because of this separated constant. Okay, and now we have to find out the general integral for this. What is the general integral? We have to substitute one constant is a function of another in the complete integral. So c is equal to phi of a in the complete integral. Again we have to substitute it. Okay, substituting z is equal to root a into root of 1 plus x square plus a y square by 2 plus the c is replaced by phi of a. Now 2 constant in the complete integral is reduced due to single arbitrary constant. Differentiating this partially with respect to the constant a, then you have dou z by dou a, which is 0, is equal to, this term is constant because we are differentiating with respect to a. So root of 1 plus x square into root a differentiation is 1 by 2 root a plus y square by 2, right, as it is. Differentiation of a with respect to a is 1 plus differentiation of phi of a is phi dash of a. Number that equation has 4. Now we we can't simplify further because we doesn't know the function phi of a. So we conclude our result, there is no eliminating 3 and 4, eliminating a between 3 and 4, we can get the general integral. Okay, and now we will see one more problem. Find the complete integral of p plus q is equal to sin x plus sin y. Number the given problem as equation 1, and here we identify the problem type. This is P, Q, X, Y is present. So this is type 4 separable equations type of problem. So that we have to find out the solution. In our problem is asked to find complete integral alone. So no need to find out singular and general integrals or general solutions. Okay. Before you write these complete integral, you have to write this is the separable equations. F of x comma p is equal to phi of y comma q, and then as usual you have to separate p terms together and q terms together and equate it to some constant a. So p minus sin x is equal to sin y minus q. There is sin x is taken to this side, it becomes minus sin x. So you have p minus sin x is equal to, and you take that q to other side, the minus q you have, so sin y minus q, which is equated to some constant a, and we say that each is equated to the some constant a. So p minus sin x is equated to a and sin y minus q is equated to a. From this, p is equal to take sin x to other side. Minus sin x, when you taking minus sin x to your right hand side, it becomes plus sin x. So p is equal to a plus sin x and q is equal to sin y minus a. Now these values of a, p and q are substituted in dz is equal to p dx plus q dy. So dz is equal to a plus sin x into dx plus sin y minus a into dy. You have to integrate this. Integrating, integral dz is equal to integral of a plus sin x into dx plus integral sin y minus a into dy. So dz is equal to a into dx is x, the integration of sin x is minus cos x, and here plus sin y integration is sin y minus cos y, and minus ay plus a constant. This is our required complete integral, because this equation consists of two arbitrary constants a and c, because complete integral always have two arbitrary constants. Okay, and that's it for this video. If you have any doubts in this, please provide in the comment section. Thanks for watching. Keep watching Alpha Numeric Tricks for more videos. Thank you.